Right, let's go through this homework. Right, so you've got the first one. This diagram shows a trapezium, all measurements on here. So you need to remember how to find the area of a trapezium because they give you some information here. The area of a trapezium is you add the top and the bottom, so it's A plus B, then halved, and then multiplied by the height, and the height is here. Okay, so that's the height. So we need to do half times, in brackets, we're going to have x plus 5 plus 3x minus 2 times by 2x minus 3. All right, lots of tidying up to do here. So a half times, and let's tidy this up. So here we've got x plus 3x is 4x, and then 5 take away 2 is 3 times by 2x minus 3. Okay, I think I'm going to do the multiplication between the two brackets next. So I am going to draw my grid. I'll just draw it here. And I'm going to work out what 4x plus 3 times 2x minus 3 is. Fill it in. That's 8x squared, 6x, minus 12x, minus 9. I put together my like terms. So these two. And my answer is half times 8x squared. 6x take away 12x is minus 6x minus 9. Okay. And that's meant to equal 133. So I'm going to get rid of the half x by multiplying both sides by 2. And that gets rid of it. So, or dividing by a half is the same as timesing it all by 2. So times by 2 here just gets rid of that. Times by 2. And so now I have the equation that 8x squared minus 6x minus 9 equals 266. Bring it all over on one side. So I'm going to subtract 266 from both sides. And I get that 8x squared minus 6x minus 275 equals 0. And that's exactly what they wanted us to show. So we've got that. So that's fine. So that's the first bit. That was 3 marks. And then they want you to find the value of x. So there's lots of different ways we can do it. We can complete the square. We can use the quadratic formula, which some of you quite like. I'm going to see if I can factorize it. Let's have a look, because they're quite big numbers actually. It's worth 3 marks. I'm going to try and factorize. All right, so 8 times 275 gives you 2,200. So I am looking for 2 numbers No, actually, I'm going to use the quadratic formula. These numbers are too big. So I'm going to use the quadratic formula. Yeah, too big. Right, so x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So x equals b minus b. So this is this bit. So it's already minus 6. So it becomes positive plus or minus minus 6 squared. Take away 4 times a, which in this case, we've got a being 8, times c, and in this case, c is minus 275. So times minus 275 all over 2 times 8. And so you could do that on your calculator. So we've got, so I'll do it up here to allow myself some room. So we've got x equals 6 plus or minus square root. So we've got 36, take away 4 times 8 times 275, which gives you minus, take away minus 8,800 over 16. X equals 6 plus or minus square root of 36 plus 8,800. This gives us 8,836 over 16. So let's do that. So what's the square root of 8,836? Actually does give you a round numbers 94. So 6 plus or minus 94 over 16. So the first one we'll do 6 plus 94, which gives us 100, and then divide that by 16. It gives us 6.25, or 6 take away 94 divided by 16, which gives us x equals minus 5.5. Okay, well, because we're talking about length, only one of these can be possible. So we put down both. Solutions, but this one is impossible because we're talking about the length of a trapezium, and we cannot have negative lengths. So that one would be impossible. So x must only be 6.25. Quite a lot for 3 marks, but there we go. Right, make R the subject here. So all we have to do is A equals 4 pi R squared. We want R the subject. So we're going to divide by 4 pi to get the A over 4 pi equals R squared. Then we square root both sides to give us that R equals the square root of A over 4 pi. And that's done. Okay, make T the subject here. So we're going to have to expand the brackets. So we get 5t minus 5g equals 2t plus 7. Bring the t's onto one side. So I'm going to subtract 2t from both sides. And I get 3t minus 5g equals 7. I'll take the 5g over onto the other side. So I get 3t equals 7 plus 5g, and then divide by 3. So I get t equals 7 plus 5g over 3. Okay, right, next one. Again, x appears in both sides. So first of all, I'm going to multiply by cx plus d on both sides. So cx plus d on both sides just gets rid of it here. And what I get on this side is y times cx plus d equals ax plus b. Multiply at the brackets, I get cxy plus dy equals ax plus b. Put everything with x on one side and then the rest on the other side. So I am going to have here cxy, take away ax, equals b, take away dy. Then I'm going to factorise. So I'll do it over here to allow lots of room. So take x out and I get cy minus a equals b take away dy. And then I can just divide. So I get x equals b take away dy all over cy minus a. Okay, nice and easy, kind of. All right, let's go on to the next one. Again, we want to make x a subject. Let's deal with the square root first by squaring. So I've got y squared equals 3x minus 2 over x plus 1. So all I've done is get rid of the square root by squaring both sides. And then I'm going to do what I did in the previous question. I'm going to multiply by x plus 1. So y squared times x plus 1 equals 3x minus 2. Multiply out the brackets and I get x times y squared plus y squared equals 3x minus 2. I'll do it up here. Everything with x in it, put it onto one side. So here I've got x y squared minus 3x equals, and I put on the other side anything that doesn't have an x with it. So minus 2 take away y squared goes on to the other side. Then I'm going to factorise. So x out and I have y squared minus 3. Inside the brackets equals minus 2 minus y squared. Then I can divide, and so I get x equals minus 2 minus y squared all over y squared minus 3. Okay, perfect. And you might have different signs to me. If you put everything on the other side and they all become out positive, then you will have different signs to me. But double check your answer with me and we'll see whether you are correct or not. Next one, make y the subject. So you've got y equals, so we've got y in both places. So first of all, let's get rid of the square root. So then I've got y squared equals ay squared plus n. I'm going to take the ay squared onto the other side so that I've got all the y's in one place. Equals n. Then factorise so that I've got y out. And in fact, I could take y squared out. Am I going to take y squared out? Yes, I'm going to have to because I can't have a y inside the brackets. I'm going to take y squared out. 1 take away a equals n. Then I divide, so y squared equals n divided by 1 minus a. And then I'm going to have to square root. So y equals the square root of n over 1 minus a. So that was a bit of a tricky one, but 5 marks. So worth doing and worth starting. Okay, let's carry on. Make R the subject, again, where R is positive. So it's again in 2 places, but I've already put them all in the same place. So all I'm going to do is factorise. I'm going to have to take R squared out. And so what I'll have inside the brackets is 4 minus pi. Then I can divide by 4 minus pi to get that R squared equals a divided by 4 minus pi. And then I square root. And so my answer is R equals the square root of a over 4 minus pi. Nice and easy. Okay, let's keep going. Was that the last one I asked you to do? No, it wasn't. Solve the simultaneous equations. Okay, so neither the coefficients of x or y are the same. So I'm going to make the coefficients of x the same in this. I'm going to times it by 2. If you did something different, that's fine. Just check it with me if you're not sure. So 4x plus 5y equals 4. Then I've multiplied the whole of the second equation by 2 to get 4x minus 2y equals 18. I'm going to subtract because the signs are the same. They're both positive 4x. Remember our stop. Yeah. So same. You take away. Opposite signs. You plus. Okay. So same we're taking away. So 4x take away 4x, 0, disappears. Be careful, now we've got 5y, take away minus 2y, so that becomes plus. So we've got 7y here. And then we've got 4 take away 18, which is minus 14. Divide by 7 and we get y equals minus 2. Now we need to substitute back in. Doesn't matter which one you substitute back into, but I'm actually going to substitute back into the original here. And so I'm going to write 2x minus 2, because I know that y is minus 2, equals 9. And so I get 2x plus 2, because these two combine to make plus, equals 9. Take away 2 from both sides, and I get 2x equals 7. And so x must be 3.5, or 3.5, or 7 over 2. Next, solve these simultaneous equations. Again, we need to make either the coefficients of x the same or the coefficients of y the same. So I am going to make the coefficients of y this time the same. So I'm going to multiply all of this by 5 and all of these by 2. Okay. On the top, I get 35x minus 10y, and then 34 times 5 is 170. On the bottom, I get 6x plus 10y equals minus 6. Okay, because I'm getting rid of the y's, you can see here that the signs are not the same. They are opposite. So because they're opposite, I'm going to add the 2. So I'm going to add. So 35x plus 6x is 41x. Minus 10 plus 10 is 0, so they disappear. Equals 170 plus minus 6, which is 164. And then I'm going to do 164 divided by 41, which gives me 4. So x equals 4. I've got that. Now I need to substitute back into any of my equations. Again, I'm going to go into, with the second one. And so I'm going to substitute x equals 4. So instead of writing 3x, I'm going to write 3 times 4 plus 5y equals minus 3. 3 times 4 is 12 plus 5y equals minus 3. Take away 12 from both sides and I get 5y equals minus 15. Divide by 5 and I get that y equals minus 3. And that's my answer. Right, solve these two. So we've got a quadratic here. And I'm just trying to think the best way. I am going to do a substitution. I'm going to change this one around. So change this one around so that x equals 1 plus 2y. And then I'm going to substitute it into the first equation. So I'm going to substitute it into here. So wherever I see x, I'm going to write 1 plus 2y instead. So at the top, I've got 3 times x, but I'm going to put 1 plus 2y instead, times by y. Okay? Minus y squared equals 8. Okay, so I've got rid of the x's because I substituted y plus 2y in there. So let's go. So I've got multiply out the brackets, so expand 3y plus 6y squared minus y squared equals 8. Tidy up, and I have, in fact, let's see, 3y plus 5y squared equals 8. Take it all onto one side. I'm going to take the 8 over here so that I now have an equation I can solve, which is 5y squared plus 3y minus 8 equals 0. Right, let's hope I can factorise this. So 5 times minus 8 is minus 40. So two numbers that multiply to make minus 40 but add to make 3. That would be, but add to make 3 would be positive 8. Yeah, positive 8 and minus 3. No, minus 5. I don't know why I said that. Minus 5. So positive 8 and minus 5. Okay. And then, so I rewrite it. 5y squared minus 5y plus 8y minus 8. Squiggly line down the middle. Factorise this side and I take the 5y out. Get y minus 1 plus 1 is the biggest number that I can take out of 8 and 8. Sorry, 8 is the biggest number, so 8 comes out, sorry. And then I have y minus 1. So then factorising, I'm running out of space here. So factorising, I have 5y plus 8 and y minus 1 equals 0. So my two solutions are y equals minus 8/5 or y equals positive 1. Okay, but that's not the end. That's why it's a 5 marker. So that's not the end. We need to go back into this one here and find our x values. So sorry, I am running out of room, but hopefully you're still following this. So I'll put my x values up here. X equals 1 plus 2y, so minus 8/5 for the first one. So x equals 1 plus minus 16 over 5, which would give me, trying to do this in my head, minus 11 over 5. Obviously check this with your calculators that I've got this right, and you're going to check it against the mark scheme anyway. And then I've got to substitute in the other y value, so x equals 1 plus 2y, 2 times 1. So this one's nice and easy. 1 plus 2 equals 3. And so there are all my solutions. Let me just highlight them for you. These are all my solutions. Here, 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 and here. Okay. Right, number 20. Is that the last one? No. Number 20, the line with the equation y equals x plus 2 intersects the curve with the equation x squared plus y squared, take away 2y equals 24 at the points A and B. To find the coordinates A and B, we are going to have to solve them simultaneously, which I did give you the clue. And so it's already been rearranged for us, y equals x plus 2. So wherever I see y, I am going to replace with x plus 2. So x squared plus, instead of writing y squared, I'm going to write x plus 2 squared instead. And then instead of writing minus 2y, I'm going to write minus 2 times x plus 2 equals 24. So all I've done is here and here, wherever I saw y, I replaced it with x plus 2. So tidy it up, I get x squared plus x plus 2 squared. Don't forget, draw out your grid just in case you end up missing out any terms. So you get x squared, 2x here, 4, gather like terms. So what you've actually got is x squared plus 4x plus 4 minus, now I expand this bracket, minus 2x minus 4 equals 24. Right, let's tidy up now. X squared plus x squared gives you 2x squared. Then I've got 4x minus 2x, which gives you plus 2x. Oops. And then I've got 4 minus 4, which is 0. And then I'm going to take the 24 over to the other side. So I'm going to minus 24 equals 0. Now, luckily, I can divide it all by 2. And if you can divide everything by 2, then that's fine. Then you don't need to do anything else. So you've got x squared plus x, take away 12 equals 0. And we should be able to factorise that. Let's factorise. 2 numbers that multiply to make minus 12, but add to make positive 1. So that is plus 4 and minus 3 equals 0. So my two solutions are x equals minus 4 or x equals 3. Then I need to find my y values. And to find my y values, I'm going to go back into here. So y equals x plus 2. So minus 4 plus 2 is minus 2. And then here, y equals x plus 2, 3 plus 2, y equals 5. So my coordinates then are, I'm going to go into this question because at least I didn't get you to do this one. So my points are minus 4, minus 2, which I got from here, and 3, 5. So they're the 2 points where they intersect, where the curve and the line intersect. Right, let's go. So we've got here, this is clearly going to be a simultaneous equation question. So let's go straight into it. Alison buys 5 apples plus 3 pears for a total of $1.96. And Greg buys 3 apples plus 2 pears for a total of $1.22. Michael buys 10 apples and 10 pears. Work out how much Michael pays for his 10 apples and 10 pears. Okay, let's go straight into it. Let's solve this. I'm going to multiply. Let's make the p's the same. So I'm going to multiply this all by 2 and all of this by 3. And that will make the p's the same. So I get 10a plus 6p equals 392. And then on the bottom I get 9a plus 6p equals, is that 122 times 3? 366. Because the 6p's are the same sign, I'm going to subtract. 10a take away 9a is 1a. 6p take away 6p is 0, so that's gone. And then we've got 392 take away 366, which gives you, 392 take away 366. What's that? 26p. Or 26 cents in this case, because we're working in dollars, so that's fine. So that's fine. So 10 apples, 10a would be 10 times, so $2, $2.60. And then to work out the pears, we're going to go back into one of the equations. Which one should I go back into? I think I'm going to go back into this one. And I'm going to write, 3a. So 3 times 0.6, 0.26. Plus 2p equals 122. So 3 times 0.26 is 0.78. Plus 2p equals 122. Take away 0.278 from both sides. I get 2p equals 0.44. So 1 pear must be 22 cents. So then 10a is $2.20. So all in all, we are spending $4.80 on 10 apples and 10 pears. Okay. Then, is that the last one that we're doing? Yeah. Okay. So now we're going to solve this simultaneous equation. All right, so it's a lot like the ones we've done before. A little bit of work on this one. So we're going to change it around. So leave x on this side. And then take the 2y and the -1 to the other side. So that I get 1 minus 2y on the other side. So the signs just changed because I've taken it to the other side. Then I'm going to substitute them all into the first equation. So wherever I see x, I'm going to replace it with 1 minus 2y. So here, I'm going to replace it with 1 minus 2y. So I've got 1 minus 2y all squared minus 9y minus 1 minus 2y equals 2y squared minus 12. Then we need to tidy up. We need to multiply out the brackets, expand all the brackets. Again, draw the grid just to make sure that you get all the terms. So 1 minus 2y multiplied by another 1 minus 2y. When we fill it in, we get 1 minus 2y here, minus 2y, and positive 4y squared. Gather like terms. So here I've got 1 minus 4y plus 4y squared. Oops, sorry, my pen is playing up. Minus 9y. Now be careful with this one. Minus 1. Then I've got take away minus 2. So it's plus 2y. So it's plus 2y equals 2y squared minus 12. Right, we've got a lot of tidying up to do. So I am going to bring all my y squareds together. So let's do it all in one go. So I'm going to do 4y squared, take away 2y squared. And that gives me 2y squared. Then I'm going to do minus 4y, take away 9y, which gives me 13y, plus 2y, gives me minus 11y. So that just gives me minus 11y. And then the last thing I need to put together is my constants. So I've got 1, take away 1, which is 0. But I'm going to bring the minus 12 onto the other side. So I get plus 12 equals 0. I can't divide them all by 2, so I've got to leave it like that and factorise from there. So let's do this. So 2 times 12 is 24. So I'm looking for two numbers that multiply to make 24, but add to make minus 11, and that would be minus 8 and minus 3. Let's write them out. So 2y squared minus 8y minus 3y plus 12 equals 0. Squiggly line down the middle, factorise, take out the 2y, and I get y minus 4. Take away. 3 is the biggest number that goes into 3 and 12, so I take out the 3, and I've got y minus 4 again on this side equals 0. And then I put together my brackets 2y minus 3 and y minus 4 equals 0. So my two solutions are y equals 3 over 2 or y equals 4. So those are my two solutions. But I'm not finished. I need to find my x now. So I'm going to go back into this one here. And I'll do it down here. So x equals 1, take away 2 times 3 over 2. So equals 1 take away 6 over 2. 6 equals minus 4. So that's minus 4 over 2, which is just minus 2. And then I do the other one, which is x equals 1 take away 2 times 4. So x equals 1 take away 8. So x is minus 7. So my 4 solutions are y equals 3 over 2, and x equals minus 2, y equals 4, and x equals minus 7.